Alright, I've converted 6.1 and 6.2 into the same lesson. It's about polynomials. I know we've talked about them before, but we will remind you what they are and how to add and subtract them. Boop. Simply put, a polynomial is just a math phrase. Separated where we have terms separated by addition and subtraction signs. I know in these examples I put just positive or additions, so there's a little minus to show you that it can be minuses, add additions or subtractions as well. So the key, yeah, so that's all it is. It's just a math phrase. It's just a math phrase. That's what a polynomial is. And depending on the amount, we have different names on them. So see, we have 1, 2, 3 terms here. We call that a trinomial. Here we have 2 terms. We call that a binomial. And here we have another trinomial. But you can just call them polynomials. That's fine too. Poly meaning multiple. We also see that with polygon, meaning multiple sides. Yeah, so it's just another math sentence. And sometimes we'll have instances where two of these phrases interact with each other and we may need to add or subtract them. And I'll go ahead and show you how to do that. Okay, here we have two polynomials that are trying to combine with each other. There's one, here's the other, and they're getting added with each other. So let's stop and make some observations. Here we have a trinomial, 3 terms. Here we have a, just call it a polynomial with 4 terms. Notice we're only working with one variable, x, but notice they are broken up in their terms. And remember, term is the parts separated by addition or subtraction signs. So remember the sign is associated with the thing that follows it. So notice how we have an x term, an x to the power of 2, x to the power of 3. When we're dealing with polynomials, we also call these the degree. This term is degree, this term, including the sign, is degree 2. This term is degree 1. This term 1. This term is degree 0. This term is degree 3. And when we talk about the polynomial as a whole, we just refer to the largest degree, which in this case is 3. This one, it is a degree 3 polynomial as well. Just some lingo to learn. All right, so let's add them together. So there's nothing we can distribute through this set of parentheses, so we can just drop the parentheses. 5x cubed plus 8x squared minus 3x plus 1, and then distribute the positive through, which means everything keeps its sign for x minus 5. Now, remember, when we're adding and subtracting terms, what are the rules? We can only combine things that have the same variables and the same exponents on those variables. So what some people like to do is make shapes around the things with the same variables. We'll do squares for the 3's, circles for the x's, and we'll do underlines for the nons. So we got 5x cubed plus x cubed. And remember, when we're adding and subtracting, we just look at the coefficient. So that's 5 plus 1. It gives us 6x cubed. There's nothing to add to the 8x squared, so we keep it. Negative 3x minus 4x is negative 7x. And then 1 minus 5 is negative 4. And there we have a polynomial that we cannot reduce anymore. So that's all we have to do to combine these two polynomials. Alright, here we have two polynomials trying to combine with each other through subtraction. There's one of them, there's the other. Let's do some observations. Trinomial, 3 terms, another trinomial. This one has a degree of 2 because that's the highest degree of the polynomial. This one also has a degree of 2. Alright, so let's drop the parentheses. This one doesn't have anything to distribute, so the signs stay the same. This one has a negative to distribute, so the signs will flip on all terms. And now, combine like terms. Let's make our 2's squares, our 1's circles, and our nons underlines. Negative 5x squared minus 2x squared is negative 7x squared. Negative 8x plus 3x is negative 5x. 3 plus 12 is 15. There we go. We got ourselves the simplified polynomial. Yeah, this is just a simplification process because we are combining like terms to make it into this, and the key phrase for this whole lesson is combine like terms. Write that down in your notes. Combine like terms. Now, starting this lesson, and I haven't read through the whole book yet, so I can only guess, but starting in the polynomial chapters, you may notice that there aren't as many word problems or word examples, and that's because there's not a lot of everyday instances where we would use, where we would need to set up turn the English sentence into a math sentence that includes polynomials. And that's just because normal people like to do simple things instead of, they'll go for easier options than something that would require a polynomial. But just because there's no English equivalence simple English equivalence doesn't mean that they don't exist. Obviously, they do exist in English, otherwise we wouldn't have them in math. But just be aware that we're not going to have as many word problems, so we're kind of just going to be working in the math language for a lot of these things. But once they do introduce the English that goes with it, you'll know how to work with it because we would have worked in the math language for so long. Anyway, sounds a little complicated, a little wordy. The point is, this is where a lot of people drop off in math because there's not as much of the English stuff they know, and it just seems like we're working with numbers and variables, and we are, but I'm just telling you that it pays off later. So anyway, moving on. All right, here we have two polynomials trying to combine through subtraction. Here's one polynomial, here's the other. Observations, trinomial, degree 3, big polynomial, degree 4. Let's drop the parentheses. This one has nothing to distribute, so everything stays the same. The one on the right has to distribute the negative, which means everything on the inside, the signs will flip. So instead of positive x cubed, 5x cubed negative, negative 8x, negative 7. And now we're combining like terms. Let's do circles for the 3's. That's a square. Squares for the 3's, circles for the 1's, and underlines for the others. All right, 6x4, nothing to combine with. Combine the 3's, that's going to give us 3x cubed. Combine the 2's, nothing to combine with, stays the same. Combine the 1's, negative 15x. Combine the others, minus 8. And notice, when we are working with polynomials, we always want to keep it in descending order of the degrees. 4, 3, 2, 1, 0. 4, 3, 2, 1, 0. That way it just stays nice and organized. So we end up with a 5-term polynomial, degree 4. That's pretty much all there is to adding and subtracting polynomials. Like I said, the key word is combine like terms. That's how you want to think of it. Other than that, our order of operations and such stays the same. The end.